Have you ever wondered how some developers complete massive housing projects months ahead of schedule while others fall behind? Welcome to the Precast Concrete Show by Modular Pulse. I'm your host Roshan Baldevan. Whether you're a business owner, construction professional, student, or just someone curious about modern construction methods, you are in the right place. At Modular Pulse, we help companies set up precast concrete factories, provide training in cutting-edge technologies like 3D concrete printing and ultra-high performance concrete (UHPC), and guide businesses on how to leverage this technology for faster, more efficient construction. Consider the Lincoln Heights project in Portland, finished 47 days early through innovative construction approaches. The secret lies in smart modular design in precast concrete construction. Prefabricated elements dramatically accelerate timelines, particularly during the structural phase of development. This standardization method is remarkably effective. The CSA Public Policy Center found it accelerates construction timelines by 25 to 50%. In this episode, I'll reveal the hidden principles of modular precast that let you build faster without creating those cookie-cutter buildings everyone hates. You'll see exactly how to maintain unique aesthetics while saving your precious time. The speed-quality paradox in modular precast. What if I told you the fastest way to build is also the fastest way to get consistent quality? Let's unpack this counterintuitive truth. There's a deeply ingrained belief in construction that quality requires time. The craftsman carefully measuring twice and cutting once. The meticulous attention to detail that can't be rushed. We've all heard the warnings, rush the job and you'll pay for it later. But what if this fundamental assumption breaks down when we examine modular precast construction? In traditional construction, quality fluctuates widely. Perfect conditions one day give way to rain, absent key personnel, and delayed materials the next, creating a roller coaster of quality outcomes that the industry has simply accepted as inevitable. The factory environment where precast modules are manufactured transforms this equation completely. Like comparing a chaotic street vendor setup to a precision-engineered restaurant kitchen. The modular approach brings order to chaos. Each module progresses through specialized stations where teams perfect specific tasks through repetition. Temperature and humidity remain constant regardless of external weather. Concrete cures under ideal conditions, monitored by sensors rather than guesswork. This control setting enables precision engineering beyond what traditional sites can achieve. Components crafted with millimeter tolerances fit together as designed, eliminating those on-site adjustments that often compromise structural integrity. The Modular Building Institute, the industry's leading non-profit trade organization, identifies these control conditions as fundamental to superior quality. Their extensive field research demonstrates how environmental control translates directly to structural excellence. Similarly, McKinsey and Company, whose construction productivity research spans decades, highlights a remarkable contrast. While conventional construction productivity has remained flat for generations, manufacturing sectors consistently achieve productivity gains of up to 3.6% annually. By applying manufacturing principles to construction, modular methods break this productivity plateau. Quality control in factory settings follows an entirely different model than on-site inspections. Rather than building first and inspecting later, modular factories integrate continuous inspection throughout production. Issues are identified immediately, not discovered weeks later when they've been covered by subsequent work. The inspection density tells the story. Conventional construction might include 3-4 major inspections, while factory production incorporates 15 to 20 quality checks for the same structure. Each check focuses on specific elements before the work advances to the next station, creating a multi-layered quality assurance system that catches issues traditional methods miss. Weather independence creates another substantial quality advantage. While traditional sites struggle with environmental challenges, factory production continues unaffected. Structural integrity never suffers from rushed work or environmental factors, a consistency traditional methods cannot match. These advantages translate to impressive time savings. The CSA Public Policy Center confirms that modular methods achieve completion rates 25 to 50% faster than conventional approaches while maintaining higher quality standards. Transformative efficiency that changes project economics. This speed comes without quality compromise. In fact, modules typically exceed building code requirements because they must withstand transportation stresses. What other construction method builds stronger than required construction practice? For project managers accustomed to weather delays, labor shortages, and quality inconsistencies, modular precast offers a revolutionary alternative. Timelines become predictable, quality becomes consistent, and the finished product demonstrates none of the compromises traditionally associated with accelerated construction. Standardization without sacrificing design. Beyond quality and speed lies the design question that troubles many architects and developers. Does modular mean monotonous? The prevailing assumption is that standardization stifles creativity, forcing us to choose between efficiency and design innovation. But this is a false dichotomy. The construction industry has discovered a powerful concept called hidden standardization. This approach maintains identical structure components throughout multiple projects while allowing for complete customization of visible elements. Think of it like automobile manufacturing. Many different car models share the same underlying chassis and engine components while expressing unique exterior styling. Standardization happens where it matters for efficiency. Custom designs appear where it matters for identity. This balancing act addresses a fundamental challenge in modern construction, achieving economics of scale while satisfying market demands for distinctive buildings. Buyers desire homes for unique character, yet developers need standardization's cost benefit to make projects more viable. The solution lies in understanding which element defines the building's character. Standardized components are floor slabs, load-bearing walls, ceiling elements, and invisible skeleton. Customizable elements are exterior finish, window configuration, balcony design, roof treatments, the visible personality. A limited set of molds become building blocks for countless configurations. Units combined side by side or stack vertically to create various housing layouts, from studios to multi-bedroom apartments. Existing structures can expand through additional modules, allowing phased development for adaptation to changed needs. This approach transforms identical structure cores into building with distinct architectural personality. A development might feature glass-heavy facades near commercial areas while using traditional brick finishes adjacent to historic neighborhoods, all using the same underlying components. The casual observer would never suspect that these buildings share identical DNA. The American Institute for Architects notes that successful implementation requires early collaboration between architects and fabricators. When architects understand manufacturing constraints from the beginning, they design within those parameters while achieving distinctive results. This partnership transforms limitations into opportunities for integrating unique design elements that respect both aesthetic goals and production realities. Financially, this approach offers substantial advantages. The investment in standardized molds gets amortized across dozens or hundreds of uses, dramatically improving return on design costs. However, there's a crucial balance to maintain. Consider the cautionary tale of a developer who insisted on custom structural components for each building in a multi-unit development. What seemed like minor modifications required new engineering, testing, and production process for each variation, ultimately delaying the project by months and increasing costs by 40%. The most successful projects recognize that customization delivers greatest impact. Structural components hidden within walls rarely influence the building's character, while entrance designs and the exterior materials dramatically shape how people experience the space. This is where many first-time modular developers stumble. When everything is customized, nothing is truly optimized. The key is identifying which 20% of design elements creates 80% of visual distinctiveness. Then standardize everything else. This targeted approach preserves both efficiency of mass production and the uniqueness that the residents or communities desire. As we've explored throughout this episode, modular construction is fundamentally more sustainable while being faster. The MIC method significantly reduces environmental impact compared to conventional building techniques. Modular approaches dramatically reduce wood waste, eliminate methane-producing landfill materials, and create higher circularity for previously discarded resources. Your next modular project represents an opportunity for faster construction, distinctive design, and environmental responsibility. By determining which elements require customization and which can be standardized, you optimize efficiency while creating a legacy of sustainability for future generations. Every decision in modular design transforms your project while participating in construction's sustainable future. Imagine how this approach could revolutionize your next build. Thank you for joining me today. If you found value in this episode, please subscribe and share it with your network. Stay curious, stay inspired, and I'll catch you in the next episode.